Hi there, geometry students. Today we are going to be starting up lesson 3, looking at the surface area of pyramids and cones. So today we're going to focus on pyramids, and tomorrow in class we're going to focus on cones. So go ahead and open up to page 6. So we're starting off looking at pyramids. So we're going to start off with the definition of it. It's a polyhedron in which one face, which we call the base, is a polygon, and the other faces, which we call lateral faces, are triangles that meet at a common vertex. So we can look at the visual down here. We see we have a base, and all our other faces are going to be triangles. So I did draw a line going down the middle of one of the triangles, as well as a line going from the top vertex all the way down to the base. We're going to go ahead and label each of those pieces. So the one that I have in purple is actually called our slant height. So we can go ahead and label that on our picture. And obviously we know that this is going to be our normal height since it is from our base to the vertex. So we can also call that our altitude. So we're going to label that as our altitude or height H. Now, currently, we have a regular pyramid right here. There's a couple of properties that we can see about our regular pyramid. With a regular pyramid, we're going to see the base is actually going to be a regular polygon. We're going to have the lateral faces being congruent isosceles triangles, since we can see that all these edges will be the same. And then our last piece with a regular pyramid is our slant height. So our slant height is really the height of one of our triangles. So we're looking at these triangles there. So we're going to go ahead and continue downward and start to build on the formula of these regular pyramids. And we're going to look at the lateral area and the surface area. So the way that I always say this is the lateral surface area and the total surface area. So looking at this, we're going to say that the lateral surface area of our regular pyramid, so remember it has the properties that we have above, all right? So the lateral area of a regular pyramid is half the product of the perimeter of the base and the slant height. So we're going to use the letter L, kind of a cursive L for slant height, and we're going to write this in words. So the lateral area is 1/2 of the perimeter of our base times the slant height L. Now, our surface area, remember, it's really going to be the lateral surface area, what we come up with up here, and then what we're going to do is we're going to add on our extra base at the bottom. So it's going to be, the sum of the lateral area and the area of the base. So we can fill that in as so. So we're going to go ahead and practice using both of these formulas. Again, remember, these are on regular pyramids. So remember, they follow all the properties that we have listed up above here with our regular polygons. All right, so we are going to find the surface area of our square pyramid. So we can see it is a square here. So going over our formulas again, the lateral surface area formula is going to be 1/2 times the perimeter of the base times the slant height. So looking at this, we're given the slant height of 5. The perimeter, since we know this is a square, that means all 4 of those sides are congruent. So the perimeter is going to be 40. So we're essentially going to be having 1/2 times 40 times 5. So when we do that, we end up getting 100 centimeters squared. So that's our lateral surface area. And keep in mind, we could also label that 5 centimeters as L. I just forgot to do that before. And I forgot to write down that our perimeter is going to be 40. So keep in mind now for our total surface area, right? We always write it as TSA. We know that is going to be the lateral surface area plus our area of our base. Now keep in mind the area of our base down here, right? This is a square. It's one side times the other. So really it's going to be 100 times 100. Sorry, it's going to be 10 times 10. So that way we get 100. So really we're taking the 100 that we got up here and we're going to add it to this base area of 100. So 100 plus 100 is 200. So we have our total surface area as 200 centimeters squared. Now let's go ahead and head to the next page to practice a couple more problems where we're not necessarily looking at a square pyramid, but different types of pyramids. All right, so we're on the next page. I'm actually going to have you make a quick correction in example number 2. It says in the directions, find the surface area of the hexagonal prism. Correct that word so it's pyramid. This should be hexagonal pyramid with slant height of 10 centimeters. So I will tell you this problem actually relates to what we saw in one of our previous lessons. All right, so in lesson 2, if you look back on page 4, example number 3, we looked at how we could find the area of a hexagon, right? So that idea is going to come back into play here as well. I just wanted to make sure I brought it up so we can kind of remind ourselves how we can approach this problem. So let's go ahead and just reiterate what our formulas are for finding the surface area. Now, specifically, when it says surface area, that means we want the total surface area. But we really can't find the total surface area unless we know part of the lateral surface area, right? Unless we know that to add it to the area of our base. So let's start off with looking at the area formula for our lateral surface area. So for that, we know we're going to take 1/2 times our perimeter times L. So keep in mind when we're looking at this, our perimeter is going to be really 6 times 6, right? Because this length is 6. There's 6 of them, so that's how we have perimeter of 36. So we're multiplying times 1/2 of our perimeter, which is 36. And then we also have to multiply by kind of that slant height, which you're probably wondering, wait a minute, where did she get 10 from? This is actually where we kind of have to walk through our problem and see what is going to happen. Ironically, if you look back at the directions, it gave us the slant height of 10. Oh, that's right. I got that. That makes sense now. Okay, so we could honestly do the math here, figure out what we get, and lo and behold, when we multiply it all together, we end up getting 180 centimeters squared. But remember, that's the lateral surface area. So we want to find the total surface area, right? So that's really our lateral surface area plus our base. Now, the area of our base, we have to figure that out again, remember, by looking at this idea of a hexagon. So we're going to use this picture over here to help us. So remember last time we did this, we drew a center and then we kind of drew a triangle to figure out what was happening. And we put the degrees in our triangle to figure out what was happening. So I'm going to start off by doing that. So if I kind of create my triangle, as we have here, I'm not trying to give too much away just yet. I can see I have my right triangle. And remember last time we talked about it, we're taking 360, dividing it by 12 because there's 12 of these small triangles. So that way this is 30 degrees. So that means this has to be 60 degrees. So keep in mind this whole length is 6. So this whole length right here will be 6. So if we want half of that, that is going to be 3. Now keep in mind, this follows the formula of our special right triangles, the 30, 60, 90. So this is our short leg. So in order for us to kind of find, our base formula, right, it's going to be 1/2 times our radius times our perimeter. That's the area formula for looking at our hexagon. So to find this radius, right, it's our short leg times √3. So when we do that, we get 3√3. So now plugging in our formula, we're going to have our base area be 1/2 times 3√3, right? That's our radius, times our perimeter of 36. Now, when we multiply that together, again, I'm going to keep it in radical form. When I do that, I get 54√3. And again, I can plug that into the formula here. So I have 180 plus 54√3. And I could put it into the calculator, figure out what the decimal is, but I'm going to keep it in exact form just for specificity. So we have that as our total surface area, and we can label it as centimeters squared. Alrighty, so we got one more problem to do, and it's a little bit tougher, but I am going to start to help you out with it, but I will give you an opportunity to kind of fill in some of the blanks and test it on your own. so let's go ahead and look at number 3. So it says, find the lateral area and surface area. So we're finding the lateral surface area and the total surface area of a pyramid with height 12 centimeters. So it doesn't give us the slant height like we had up here. It gives us our actual height. So I actually put that in blue, so we could probably label that as 12 centimeters. And I also will tell you, all right, as we're looking through this, trying to figure things out, we probably want to figure out what the slant height is. So let's go ahead and just label that as our cursive L. We're not sure what that necessarily is. Now, looking at our picture here, right, I kind of outlined in red that we're essentially looking at half of this square. So this length right here, we could label as 5. So start to throw it back. If we have this right triangle here and we want to find this diagonal, right, that slant height, any ideas on how we could do it? I think I know what you're thinking. We know the 2 legs. We want to find the hypotenuse. Pythagorean theorem. All right, so we're doing 5 squared plus 12 squared equals L squared. Go ahead and do that. I will give you time to pause the video right here to figure out what you get as your result. All right, so if you did the work correctly, you should have gotten 25 plus 144 equals L squared. So you should have gotten 169 equals L squared. So when you take the square root, dun, 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 we get L, right? That slant height as 13. Perfect. Awesome. So now we can go ahead and plug in what we know into our formulas. So we have our lateral surface area is 1/2 times the perimeter times L, which is our slant height. And for our total surface area, as a reminder, that's our lateral surface area plus the area of our base. So pause the video again here. I want to see if you remember what you're doing, if you know what to plug into each spot, and we'll check our answers in a little bit. So go ahead, pause the video, and play it when you're ready. So in order to figure out for our lateral surface area, the perimeter, we just add all the 10s together. So essentially we're doing our perimeter of 40. Now for our base, right, that's just taking the area of this, one side times the other. So it's essentially doing 10 times 10, so we get 100. So we're going to use those when plugging them in. So I have 1/2 times my perimeter of 40 times my slant height of 13. And when we do that, you should have gotten 260 centimeters squared for the lateral surface area. Now for total surface area, we take that 260 and we're going to add it to the area of our base, which again is 100. We found that out before. So when we multiply those, we get 360 centimeters squared. So that's looking pretty good for this practice problem. So keep in mind, tomorrow's lesson, we will continue on taking notes, looking at cones, but we are done for today. So I will go ahead and see you tomorrow. Bye.